Welcome to School of Chemistry. My name is Abi Moses Ogo. If it's your first time visiting the channel, please do not forget to subscribe so that we'll be keeping you up to date with content uploaded. Today we're going to be looking at the concept of valency. What is valency? Valency simply, we call it valency or oxidation state. Simply is the combining power of an element. When an element goes into reaction, by what factor is it going to react? That's what valency is. It's actually a property of an element. Every element has its own characteristic property depending on the number of electrons it has in the valence shell. Either the number of electrons it can give out or the number of electrons it can accept. So there are distinct valencies for every element in a group. For example, elements in group 1. Now note this, before we proceed with that, note this. Every element is trying to attain a state in reaction called the octet structure. It's either you give out your electron or you gain electron. We'll be dealing with that in electronic configuration. They are trying to attain either the duplet or the octet structure, which is a stable state for every element. Now, is either element in group 1, they give out electron, or element in group 7 are accepting electrons. Is all you can understand now, though I've not treated electronic configuration. Now, the group 1 element, like sodium, because it's in group 1, we have oxidation state of +1. Magnesium in group 2 has an oxidation state of +2. Potassium in group 1 has an oxidation state of +1. Calcium in group 2 has an oxidation state of +2. We also have aluminium in group 3 with an oxidation state of +3. We have carbon in group 4 with an oxidation state of plus or minus 2, +4, and +2. It has a variable oxidation state. Then we have oxygen in group 6 with an oxidation state of -2. We have chlorine in group 7 with an oxidation state of -1. Then we have argon in group 8 with an oxidation state of 0. That means to neither accept nor give out electron. The ones with negative oxidation state are the ones that will accept electron, while the ones with positive oxidation state are the ones that will gain electron. Now, how do we write formulae from valency of elements? It's a simple rule that you must follow. If you have element X with an oxidation state of A combining with element Y with an oxidation state of B, we are trying to see how we can derive the formula of the compound that will form. First, the compound that will form, first of all, you write out the first element and you take the oxidation state or the valency of the other element and write it as a subscript by the right hand corner of the first element. So this is now going to be B. So we are simply saying you are bringing this valency, you place it here. Then you bring this valency and place it. You are exchanging the valency. Instead of writing them as superscript, you write them as subscript so that Y is going to be A. So you're going to have XB, YA. Remember, A is the valency for X and B is the valency for Y. Now when you exchange, you're going to have XB, YA. This is the way it goes. The B will come down here, while the X, the A will come here. For example, you have hydrogen reacting with oxygen. If you exchange this number and bring it here, you are going to have H2. If you bring one down to oxygen, you have O. And that is how the formula for water is being derived. Also, we have sodium combining with chlorine. This will form, this one is 1, so this one will come here. You are going to have sodium. When it's 1, you don't write the 1 again. You bring this one here, it's going to be chlorine. But when we have magnesium 2 plus reacting with chlorine minus 1, you are going to have, you bring the 1 down, so this is going to be magnesium and then chlorine, Cl2. When you have aluminium 3 plus reacting with oxygen 2 minus, what will be the formula? Do it quickly, let's see. You should get it correctly. It's going to be aluminium. If you write it correctly, you are going to bring these 2 down here. So it's going to be aluminium 2, and then you bring these 3 here. And then O3. Now we'll have what we call radicals. We defined them before. They are simply group of atoms that carries the charge. Radicals includes OH minus, NH4 plus, SO4 2 minus. All these are radicals, and they also react and form compounds. And how do they do it? Let's say if your hydrogen reacts with the sulfate ion, it will form hydrogen. Now, this radical exists like this. The minus or the sign, the valence is for all the atoms in the radical. So it will react, these 2 will come down, H2, and then SO4, because only 1 will be here. When magnesium 2 plus react with OH minus, it will form, we'll bring a 1. This is why, once you see a sign without a number, it is 1. 1 will come down here. We're going to have Mg, and then these 2 will go for the whole radical. So it's going to be OH 2 minus. So this is how we derive the formulae of compound from their valencies. Now, how do you write the formula for a compound like Ca 2 plus reacting with Cl minus? Do it quickly as we wrap up this class. Have you done it? If you do it correctly, you are going to have Ca, you bring this one down, so no need to write the number, and then Cl, the 2 will come down now, and you have 2. This is how you write the formulae of compounds from their valencies. If you have any question, don't forget to drop it under the comment section. All right, now we look at valency. We saw what valency is. We see how the valencies of elements are being derived, and we'll see how we can use these valencies to derive the formulae of compounds. Thank you very much.